Metal excess defect due to anion vacancy. So this is crystal lattice. Okay, having positive and negative ions in alternate position in an orderly manner. If one anion escapes out from the crystal lattice, a hole is created in the crystal lattice. Okay, so this is anion vacancy. Okay, and to maintain the electrical neutrality, this anion vacancy that gets occupied with the negatively charged particles which are called electrons. Okay, so here electrons occupies the anion vacancy in metals. Okay, so holes which are occupied by electrons, negatively charged particles, these are called F centers. Okay, so this is F center. So F center is also called as colored center. Okay, F center is called colored center. Okay, what is F center? If anion vacancy in a crystal which gets occupied by electrons, that is called F center. Okay, so anion vacancy in a crystal. So F centers. So F center is anion vacancy in a crystal which is occupied by electron is called F center. Okay, so the F centers are also called as colored centers. Colored center. So greater the number of F centers, greater is the intensity of color. Okay, so when F centers are more in the ionic crystal, its color also, intensity of its color also increases. So due to the presence of F centers, okay, ionic crystal, for example NaCl. NaCl is in yellow color. Okay, why? Because F centers are present in NaCl. KCl is in violet color. Potassium chloride is in violet color. And lithium chloride, that is in pink color. Okay, so due to F centers, NaCl appears in yellow color, KCl appears in violet color, and lithium chloride appears in pink color. Okay, so this is metal excess defect due to anion vacancy. Next type of defect is metal excess defect due to extra cation. Okay, so this is next type. Okay, so here in metal excess defect due to extra cation, it arises due to cation occupies interstitial position. Okay, so already sufficient number of cations and anions are there. Okay, if one more cation occupies at the interstitial position. Okay, so here metal excess is there due to extra cation. So to neutralize, to maintain the electrical neutrality, so cation which is present at the interstitial position, that is neutralized with electron which is present at the interstitial position. Okay, so cation occupies the interstitial position, extra cation Here extra cation occupies the interstitial position. So to maintain electric neutrality, one more extra electron is created at the interstitial position. It balances the charges. It balances the extra positive charge. Okay. And this type of metal excess defect that is observed in zinc oxide. Okay. When zinc oxide gets heated, we get Zn2 plus ions. So Zn2 plus ions occupies the interstitial position of that crystal, and it gets balanced with the electrons which are present at the interstitial sites. Okay. Next, metal deficiency defect. Metal deficiency defect. So this is due to absence of metal ion from the crystal lattice. So metal deficiency defect is due to, this is due to absence of metal ion. Absence of metal ion from its lattice point. Okay. And its charge is balanced by ion having high positive charge. Okay. So here absence of metal ion. Metal ion is absent. Means one cation is absent. Okay. And charge is balanced by another positive ion. So charge gets balanced by another positive ion. And generally metal deficiency defect that takes place in iron oxide, FeO. So transition metal oxide, they generally exhibit metal deficiency defect. Okay. So charge balanced by another positive ion with a high positive charge. Okay. So ion having high positive charge that balances that vacancy. Okay. Which is created due to absence of metal ion. Next, impurity defect. Last one is impurity defect. So generally impurity defect that arises due to the addition of impurity to pure crystal. Okay. For example, NaCl is there. So this is due to addition of impurity to pure crystal. Okay. So NaCl is there. Okay. This is pure crystal. If we add strontium chloride to NaCl crystal. Okay. So it gets defected. So each strontium ion, it replaces 2 sodium ions. Okay. So in NaCl crystal, Na plus ions, Cl minus ions, they are arranged like this. Na plus Cl minus, Na plus Cl minus, Na plus Cl minus, Na plus Cl minus. If you add strontium chloride to this, so strontium ion replaces 2 sodium ions. Okay. So it replaces 2 sodium ions. But one hole that is occupied by strontium ion and another one that remains as an empty hole. So this is a clear vacancy. Okay. And one hole due to the replacement of Na plus that gets occupied by strontium 2 plus ion. Here charge is 2 plus. That's why it replaces 2 sodium ions, but it occupies only one, and another one, that is a empty hole. Okay. So this is impurity defect.